Hello everyone, I welcome you all to the important topic series. So my name is Devanand, I am the faculty of heat transfer in ACE Engineering Academy, Hyderabad. So I am going to discuss today some important topic in heat transfer. See, there are multiple topics which are important, but due to the time constraint, I want you should get good score in less time. So today's agenda is in a less time how we can score in heat transfer. So that's why I selected the topic called critical thickness of insulation. Of course this topic is very easy, it's not a difficult at all. I request to all of you, this topic you can revise in half an hour also and maximum mark you can get it easily. So today my agenda is I will make you comfortable in critical thickness of insulation, and today's agenda is not about understanding of this topic in very detail. Today's agenda is to prepare according to the need of the exam. So today I am not going to derive anything, I am helping you how to solve the numericals. Okay, fine. So once again I welcome you all. Now let's start our topic. So our topic is critical thickness of insulation. Okay. So this is our topic name. Okay. So make sure that critical thickness of insulation, in that the word this is very important, that is insulation. So here we are going to talk about the insulation only. We are not going to talk anything other than that, okay, only insulation. Now the problem is, listen carefully, the problem is, let us say there is one body, okay, this is the body, right. Now suppose if I insulate this, so let us take this is insulation, okay, let us say this is insulation. So this part is insulation, okay, this part is insulation. Now whenever we said insulation, always remember K is always low. K is always low. If you are saying that it is insulation, make sure that thermal conductivity is always low. But remember one thing, K cannot be 0. Any insulator, some K value will be there. Now what is the general principle? Why we insulate this? Why we insulate this? We insulate in order to reduce the heat loss. Okay. Now as you can see, Q conduction is equal to, so minus Ka delta T by delta X. Okay, let us say as K value is low and with increasing delta X, Q conduction decreases. Why? Because K is low, this is low and thickness is increasing. But one problem is there. What is the problem? Suppose if you think about Q convection, that is HAS delta T. HAS delta T. So if you observe, due to insulation, so let us imagine there is a H outside, this is T infinite. So see, from outside there is a Q convection, agree? So from outside there is a Q convection. So due to insulation, you can understand this surface area is increasing. Why? Because you are insulating from outside, so surface area is keep on increase. If surface area increases, there is a tendency of convection increasing. Now the important concept is generally what happen? Generally we put insulation to reduce the heat loss in maximum cases, not in all cases. So suppose if you insulate and if you are relaxed, you thought like that, oh, heat transfer reduce. Now what is heat loss from that body? It is due to conduction and it is due to convection. Now Q conduction is decreasing, of course it is decreasing. but Q convection is increasing. And if I ask you, tell me whether the heat loss from the body is increasing or decreasing. Suppose if I ask heat loss from the body is increasing or decreasing, then you don't have any answer. Why? Because conduction is decreasing, convection is increasing, and we don't know the magnitude of conduction and convection increment and decrement. Suppose if I say, I will give some money, I will put some money in your account and I will remove some money from your account. Once again, if I said that I will put some money in your account and I will remove from your account some money, tell me whether you are in profit or loss. Then of course you don't have any answer, because what you will say, sir, you tell me first how much amount of money you are adding and how much amount of money you are removing. You will say one thing, right? So in that similar way, it is just a roughly approximate that conduction is decreasing, convection is increasing. So that's why we are not able to calculate the heat loss from the body, whether it is increasing or decreasing. So due to this reason, we need to study this topic, that is critical thickness of insulation. So it's all about insulation. It's all about insulation. Means what happens when you insulate with respect to thickness, what will happen? This topic is all about that. So always remember, this phenomena will come and whenever you are insulating from outside, because when you are insulating from outside, surface area is increasing, heat loss is increasing. Suppose if you insulate from inside, there is no use, because if area is decreasing, heat loss also decreasing. So this concept is useful only when you are insulating from outside area and area keep on changing. So in case of plain wall, it is no useful. In case of cylinder or sphere with inside insulation, it is not useful. It is only useful in case of cylinder and sphere when you are insulating from outside. Okay. So this is the thing you need to understand. Next point. So suppose if you write like this, Q loss is equal to delta T by R total. Okay, R total, and that R total is equal to R conduction plus R convection. Make sure that during the critical thickness of insulation, we are neglecting radiation into account. So there is no radiation at all. So what I am trying to say, see, and one more thing you need to understand, this pipe or sphere, this resistance we are not going to consider. So this resistance we are not going to consider, we are going to consider the resistance offered only by insulation, not by the pipe itself. Okay. Now what you need to do, suppose if it is cylinder, then this total resistance is Ln, any radius by R1 by 2 pi K insulation into L plus 1 by outside 2 pi R L. So this is the resistance in case of cylinder. If it is a sphere, then this RT is equal to 1 by 4 pi K insulation. This is 1 by R1 minus 1 by R plus 1 by H naught 4 pi R square. Okay. So what you need to do, just you need to differentiate resistance with respect to dr and equate to 0. So the derivation I am leaving up to you. So you need to differentiate with respect to that R and equate to 0. If you do that, listen, if you do that, then for cylinder we will get that radius is equal to K insulation by H outer, and for sphere is equal to R is equal to 2K insulation by H outer. So these are the two formulas you will get, but make sure that this is the radius you got when slope is equal to 0. By equating slope is equal to 0, Okay, equating slope is equal to 0. So this is the radius at which the total resistance is either maxima or minima. Okay, but by cross checking the double derivative, if you check its double derivative, d square rt by d r square, so this is positive. If this is positive, means this is minima point. So this is minima point, d square rt by dr square. So hence this will indicate your minimum resistance. Minimum. Okay. So this will indicate minimum resistance, right? So please listen, what is this means? Means at this radius, total resistance is, at this radius the total resistance is minimum, or you can say heat loss is maximum. So resistance is minimum means heat loss is maximum. So please listen carefully. To avoid confusion, we will just designate it as RC. To avoid confusion, just we will designate it as RC, so that it will remind us that this radius we got by equating slope is equal to 0. So by equating slope is equal to 0, we got this radius. So what is this radius is all about? This radius say that at this radius the resistance is minimum, and heat loss is maximum. And based upon that, if we plot the graph, which is very important for exam, okay. So if you plot the graph, so everyone please pay attention. If you plot the graph, so this is radius, this is Q, okay, this is Q. So now I am going to plot the graph, so be with me. This graph is something like this, okay, this graph is something like this, okay. So listen, right, so this is, just give me a second. Listen now. So this is your original radius of that pipe or sphere. This is your critical radius RC. So this is the original, this is original radius, what you manufacture, that is your original radius. So here you will get Q without insulation. So this is Q without insulation. So if there is no insulation, this is the heat transfer, okay. And this at this radius, this is Q max. That's it. So this is the graph. Now you will ask me one thing, sir, is it rule that we will manufacture less than RC only? No, there is no rule. Suppose if you manufacture here, so first take this line horizontal, okay. You may be manufacture here also. So let us say you manufacture here. This is R1. Okay, this is R1, right? So now the question is, if you are able to read this graph enough, you can solve any question. So what I am trying to say, listen carefully. At RC, this heat loss is maximum. Now it depends whether you manufacture less than R1 or greater than R1. That is choice, that is purely choice. So now the thing is that first you try to understand, for cylinder RC is equal to K by H. This is the formula. Once again, K insulation by H outer, not any K, not any H. Only this should be not K of pipe, this should be only K of insulator by H of outside. And for sphere it is 2K by H. Just listen carefully, right? And this is the graph. So now you need to understand how to read the graph. So what you need to do? what you need to do, very important, very important. So let us take this graph here. So listen, suppose if it is electric wire, listen, now if it is electric wire, right, if it is electric wire, as you know, in case of electric wire you have to insulate. Why you have to insulate? Because if you don't insulate, there is a safety issue. Due to the electric shock, some person may die. So there is a safety reason. So compulsory you have to insulate the wire. There is no other option. There is no other option. Wire has to be insulated, first thing, right? So wire has to be insulated for a safety reason. Second is, suppose if you insulate the wire, and then what happens? Suppose heat is not going outside. Suppose the heat is not going outside, and if the heat accumulate inside, so more the heat is generating and heat is not coming outside, then wire will melt. Suppose if you insulate this wire and the heat is not going outside, so this is the Q. Okay. If heat is not going outside, then the temperature will keep on increases and there is a burning of wire. So problem is what? We need to avoid the burning of wire and we need to avoid the electric shock. So please listen carefully. In case of electric wire, or conductors, okay, in case of electric wires or conductor, make sure that Q with insulation should be greater than Q without insulation. So please take care of that. In case of electric wire, Q with insulation greater than Q without insulation. Means in case of electric wire, the purpose of insulation is to enhance the heat transfer. So whatever we are insulating the wires, make sure that insulation is provided for the two reasons. One, to provide the safety from electric shock, and second, to enhance the heat transfer. Of course, this may sound opposite. Generally we insulate to reduce the heat loss, but in this case we are going to insulate for increasing the heat loss. So Q with insulation greater than Q without insulation. That is the first thing. And second thing, suppose if there is a steam pipe. Okay, what you will say? Q with insulation listen carefully, is less than Q without insulation. So please take care of that. Q with insulation less than Q without insulation. So this is the thing. Now then you will ask me one thing, that is okay. In steam pipe, whatever we are going to insulate, that Q with insulation should be less than Q without insulation. And in case of electric wires, Q with insulation should be greater than Q without insulation. Now how to deal with that? Always remember, always. So this RC, whatever we calculated this value, K by H and 2K by H for cylinder and sphere, you have to calculate before manufacturing the wire. Once again, because you know very well what type of material you are going to insulate that wire and under what environment this is going to kept. So the thing is that you have to calculate this RC before actual manufacturing. So if you know your RC value, oh, this is the critical radius, so we will get a rough idea. So what we need to do, in case of electric wire, it's easy to explain me, just wait. Okay. Now listen, what you need to do, so first you have to calculate critical radius. First we have to calculate the critical radius. Now suppose your aim is, this is your electric wire. Okay, this is your electric wire. So your aim is to enhance the heat loss from the electric wire. Okay, in that case what you need to do, please listen. Give me a second. Okay, so what you need to do, whatever your RC value is there. Okay, so let us say in electric wire RC is let us say your RC is 10 mm, 10 mm. So do one thing, either you have choice, manufacture less than RC wire, because our aim is to enhance the heat transfer. So let us imagine, assume, let us say RC is 10 mm. So what you need to do, either you manufacture less than RC or greater than RC, no problem. Generally student will think that we should always manufacture less than RC for electric wire. It's not correct. Ultimately what you need to say, see, whether you manufacture here or here, here or here, ultimately this condition has to satisfy. So this condition is what? Q with insulation greater than Q without insulation. This condition we have to satisfy. So please listen. So what we need to do, suppose your RC is 10, and suppose I manufacture by 8 mm, let us say, and in that I added the 4 mm of insulation, So what is new R? Now new R is 12 mm, okay, new R is 12 mm. So please listen carefully. This is RC is 10, R1 is 8, okay. So let us say I manufacture here, okay. This is the I manufacture. Now let us imagine this is 8 and this is RC is 10, okay, very good. Now you added 4 mm of insulation, so because of that the radius R is greater than RC, correct or not? Because it is 12 and this is 10. So now you reach to this point, So listen, now it is 12. Check whether your condition satisfied or not. So initially you manufacture 8, then you added 4 mm of insulation, now it is 12. So you are reaching to this point. So please listen carefully, you are reaching to this point. Okay, you are reaching to this point. Now always what you need to do, you need to check, this is your first point, without insulation, and this is your second point with insulation. So this difference you have to check, okay, this difference you have to check. If this value is less than this one, heat transfer, if this heat transfer is less than this, then design flop, we failed in the design. Why? Because in case of electric wire, Q with insulation should be greater than without insulation. So always remember, this is without insulation, so this is without insulation, so this should be with insulation. So with insulation should be always high, once again, where in case of electric wires. So make sure that if this point is less than this one, so heat transfer is decreasing, then this will not work out. So the thing is that it never, there is no particular rule that it should be always less than RC. It may be greater than RC. There is no standard value of critical radius. It may be less than or greater than. There is no perfect. Only thing is that you have to check without insulation, with insulation. If this satisfied, and this is the graph you have to follow. Don't worry, you may get confusion, don't worry. When I will solve the numerical, you will understand clearly. So think what I am trying to say. So just give me a second. Okay, just give me a second. Oh, sorry. Now listen, just give me a second. So this is RC, okay, this is RC, whether you can manufacture less than R1 or greater than R1. Ultimately, it depends whether you are in electric wire or steam pipe. If this condition satisfied, enough. Now listen, now look at the board. Suppose this is your with respect to radius, and this is your Q. So always remember, suppose this is the starting point, okay, this is the starting point, this is your critical thickness, something like that. So suppose if I join this curve like this, Okay, so what you need to understand, this is your original R1, this is your RC, or you can start from here also. This is your original R1. Okay, so this is RC. RC is fixed. Why RC is fixed? Because RC is equal to K insulation by H outer. Now K is not going to change, H is not going to change, so RC value is anyway fixed. Okay, very good. So it is fixed. Okay, so please listen. So if I assume this is original, so this is without Q, without, and this is your Q max. Finish. So this is your Q max. So always remember, if manufacturing radius, once again, if manufacturing radius less than critical radius, suppose manufacturing radius, you manufacture less than RC, then due to insulation, heat loss, imagine you are starting from here. If you insulate, then heat loss keep on increases. Heat loss increases, reach to max value, and then start decreases. Okay, listen carefully. When you manufacture less than RC, suppose you manufacture greater than RC directly, you know RC, right? Suppose if you manufacture greater than that, then due to insulation, heat loss always reduces. Okay, when it is greater than RC. And what is the condition for maximum heat loss? Condition for maximum heat loss. When heat loss will be maximum? When you manufacture or you insulate at RC. Okay, so this will be R is equal to RC. Okay, R is equal to RC. Listen, what I am trying to say, see, gaining knowledge is a different thing, and gaining knowledge as per the need of the exam is a different thing. So this topic, believe me, if you understand this only, कि this is RC, sometime if you manufacture less than R1 or greater than R1, and if you know this point, that in electric wire this condition, in steel pipe this condition, if you know this one well enough, you can solve any question. Make sure that you should know these two formulas. For cylinder and sphere, you should know this formula enough. If you know this one, how to use this, you can solve any question. You may be think funny that we can solve any question just because of this. Yes, it is because of this you can solve. I will show you. Okay, I will show you, but only difference is I am expecting you should know this formula. and make sure this should be always K of insulation by H of outside. That's it. These two formulae. And one common mistake where student will not differentiate properly whether it is critical radius or critical thickness. Sometime in the examination they will ask to find thickness. So make sure that radius is different, thickness is different. Now let us solve some questions so that you will have the clarity. So these are some gate questions I am going to take. Okay, listen carefully. Very simple question. All critical thickness questions are simple, not a big issue. See, what is the question? You can read it. A plastic sleeve of outer radius. So outer radius is 1 mm. So there is one sleeve of outer radius 1 mm. Covers, so this plastic covers the wire, that radius is 0.5. So that radius is 0.5. It means there is one radius wire. This is important. This is electric current. Okay. So in short, what I am trying to say, listen, there is one wire. Okay, this is the wire. This is the wire, right? This wire of radius, this one is R1. Let us write R1 symbol, that is 0.5 mm, he said. 0.5 mm. In that there is a plastic sleeve. Okay. So there is plastic sleeve. So let us say this is the plastic sleeve. Okay. Hope you get it. So this is the plastic sleeve. This is the plastic sleeve, right? What is the outer radius? 1. So this is R, that is 1 mm. 1 mm. Now thermal conductivity of the plastic. So this K of insulation, of course plastic acting like an insulation, that is 0.15 watt per meter Kelvin. 0.15 watt per meter Kelvin. The heat transfer coefficient on the outer surface of the sleeve. So H naught, that is 25, check the unit, it is watt per meter square Kelvin. Now this is the question, this is the question. In the question it is asked, due to addition of plastic cover, the heat transfer from the wire to the ambient. Okay. So due to the addition of insulation or addition of this plastic cover, what happened with the heat loss? Whether it increases, remains same, decreases or 0. So this is the question. These are the very common questions in GATE exam, right? So what you need to do, there is the electric wire of 0.5 mm radius. In that we put some covers, plastic sleeve of 1 mm, and that plastic thermal conductivity 0.15, where H naught is 25. So without wasting your time, calculate the RC first, without wasting time. So calculate the RC. If we calculate the RC, it's a wire, RC. So it's a K insulation by H outer. Okay. So K insulation, that is 0.15 by H outer, that is 25. So this RC I will calculate. So if I calculate this 0.15 divided by 25. Okay. So if I convert into, so I will get, this is 6 mm. Okay. So I will get into 6 mm. So please listen carefully, this is 6 mm. So RC is 6 mm. So you can plot it here. You can plot it here. This is the graph we have, right? So this RC is equal to 6. Okay. And what is the original radius? 0.5. So original radius is 0.5. So this is R1 is 0.5. Okay. Then we add a plastic sleeve up to the radius 1. So this is here. This is R, that is 1. That is 1. So make sure original radius R1 is less than RC. Okay. Original radius R1 is less than RC. And because of that insulation, check, this is the condition without insulation, wire, and due to that plastic sleeve, you reach to this point. You reach to this point. So check one thing, this is your Q without insulation, and this is your Q with that plastic. Q with that plastic sleeve. So hence it is visible to you. Hence it is visible to you. Because of that plastic insulation, it is increases. It is increases, right? So because it is less than RC, we put it, so we reach to this point. So Q plastic sleeve greater than Q without. So in that case, what you can say, due to addition of plastic cover, the heat transfer on the wire, this will increases. Okay. So you can understand, you can go for the option A. Of course I am teaching you, that's why I am taking time. Otherwise you can solve less than some 30 seconds also, less than 30 seconds also you can solve this question. It's not an issue. So thing is that first you need to check RC, then you need to check with this graph. So what happened with this insulation? You will get the automatically answer. Okay, this is the simple one, right? Okay, next question. This is from previous gate. What is the question is all about? Question: if a foam insulation is added, once again, if a foam insulation is added to a 4 centimeter outside diameter pipe. Okay, so this is the foam insulation, whatever dot 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 you can see, that is a foam. So this is foam, this is foam, and once again I will write down, this is K of foam given, that is 0.1 watt per meter Kelvin. Okay, right, and this H naught outside, that is 2 watt per meter square Kelvin. This is H of outside. What he asked? The critical radius of insulation in centimeter. Simple. The critical radius of insulation in centimeter he asked. So make sure that it is the direct formula base, because it is a pipe. So what is the formula? You may be say K by H, but make sure that in this case HI also given inside, H naught also given outside, K of foam also given, and K of pipe also given. But make sure that the pipe thermal conductivity we never considered, because in the assumption we will assume that neglect the thermal resistance of pipe, we neglect that, and inner HI we will not consider, because from inside insulation there is no concept of critical thickness. So if you calculate this, so RC is equal to K insulation by H outer. So K insulation, that is 0.1 by H naught, that is 2. So if you calculate, but remember you will get in meter, so you have to convert. So if you convert, then you will get into RC is 5 centimeter. So RC is 5 centimeter. Okay, so this is the case, K foam H naught and RC is 5 centimeter, right? Very simple. Only where is the chances of doing mistake? You should not use HI and you should not use K of pipe. You should use K insulation by H out. Simple question. Next one. What is this question? A 10 mm diameter electric conductors. So once again it's electric conductors. Everyone please remember, it's an electric conductor. Okay, is covered by insulation of 2 mm of thickness, very important. So 2 mm of thickness, the conductivity of the insulation given 0.08, and the convection coefficient at the insulation surface. This is the important data. Okay. What he ask? Addition of further insulation of the same material. Further insulation of the same material will. Simple. Without wasting time, first we will calculate RC. It's a wire. Okay. So it's a wire, K insulation by H outside. First we will calculate RC. So RC, this is 0.08 by, this is 10. This is 10. If you solve this, you will get 8 mm. Okay. If you solve this, you will get 8 mm. So listen, this is the critical radius. Now we have to understand, there is a 10 mm diameter electric conductor. So see, this is the wire, it is 10 mm. So this is R1, that is 5 mm. So this is 5 mm. And what is RC? 8 mm. Simple. So draw the curve. Draw the curve. This is the curve. What is RC? 8 mm. So this RC is equal to 8 mm. Next, you check R1 is 5 mm. So it is clearly visible. R1 less than RC. R1 less than RC. So it is here. Right. So this is 5. Now, What he asked the question? Addition of further insulation of the same material. So already there is an insulation of 2 mm. So make sure that there is an insulation. So 2 mm you have to add here. So here you have to add 2 mm. So this is R. So this R is equal to what? R1 plus 2 mm. So this will be 7 mm. This will be 7 mm. So now this is R1 5, this is 8, so this is R. Okay, this is 7. So this is without, this is with insulation. Already you are here. Already you are here, and this is the maximum heat loss. This is the maximum heat loss. So once again, original is 5. Already there is a 2 mm insulation, so you reach to 7 point. Now you are already here, and the question asks addition of further insulation of the same material. If we insulate further, how much did not mention in the question. How much, that is not mentioned in the question. So we will take continue. Suppose if you are here and if you keep on adding the insulation, suppose you are here and you are keep on adding the insulation like this. So check initially what happened. Initially heat loss is increasing. Initially heat loss is increasing, then heat loss will decrease. So this is the graph. So from here initially heat loss increases, then decreases. So that's why you have to select this option. So increases then decreases, increases then decreases. So this is the right answer. This is the right answer. Increases heat loss to maximum and then decreases heat loss. Right? Simple. So from this graph you can solve easily. Next one. Next one. For a current wire of 20 mm diameter exposed to air 20 and maximum heat dissipation occurs when thickness of insulation. Okay. So let us say K insulation, that is 0.5 watt per meter Kelvin. HO is equal to 20 watt per meter square Kelvin. Okay. So it's a wire. It's a wire. So RC is equal to K insulation by H outer. Okay. Right. So if you solve this, this is 0.5 by 20. I think it is 25 mm. Let me check. Okay. So this is 25 mm. So this is your critical radius. This is your critical radius. But what is asked in the question? Maximum heat dissipation occurs when thickness of insulation. Very good. Very good. Now this is the wire. This is the wire. What is that? 10. Diameter is 20. So this radius R1 is 10. R1 is 10 mm. Okay. Now as you know this graph, so this is the graph. Okay. This is R1, and for maximum heat loss this should be RC. Okay. Very important. For actually what is thickness? Actually thickness is equal to R minus R1. R minus R1. But for maximum heat loss, for maximum heat transfer, R should be is equal to RC. So you should insulate up to this RC. You should insulate up to this RC, then this become thickness. So this thickness is equal to RC minus R1. So that is 25 mm minus this is 20, so by 2, 10. So if you solve this, you will get 15 mm. If you solve this, you will get 15 mm. So make sure that most of the student will tick for here 25 mm, because they are so much hurry. Immediately they calculate the critical radius, and by critical radius immediately they thought this is the answer. But you read the question, it is clearly written that it is thickness. It is thickness. It is clearly written that it is a thickness. So that's why 25 mm is not your answer. 25 minus 10, that is your 15 mm. That is your 15 mm. So that's why your answer should be this one, 15 mm. This is the answer. Next. Next one. Next question. With an increase in the thickness of insulation, around a circular pipe, heat loss to surrounding. Simple. Already I told you, but once again, if this is the pipe, and if you, wait a minute, if you insulate this, then what will happen? This insulation will offer resistance, right? This will offer resistance. So this is conduction. So conduction will decrease, heat conduction will decrease because of this insulator, because of this material decrease, but due to increase in surface area, Q convection will increase because you are insulating from outside. So area increases, convection will increase and conduction will decrease. Simple. So you can tick this answer. Convection increase while conduction decrease. This is your answer, right? So hope you are able to understand, right? See, hope you are able to understand. Very simple topic. Now this is the thing. Now I expect that you should solve this question. You can do it. This is for your practice. Pipe of 25 mm diameter carries steam. The heat transfer coefficient between cylinder and surrounding is 5. It is proposed to reduce the heat loss from the pipe, adding insulation of thermal conductivity. So you need to calculate first RC, that is K insulation by H outer. K insulation is 0.05 by H. H is 5. So you need to calculate RC. Once you calculate RC, which of the following statement is true, he is saying. So please listen. Now in this case what happened, your manufacturing radius greater than RC. So please listen. Okay. So now this one, this is 12.5, this is, I think this is 10 mm, and your original radius is 12.5 mm. So make sure that this is the graph, this is radius, this is Q. So check. So this is your RC, this is your R1. So R1 already greater than R1 already greater than RC. You are already here. If you insulate, then heat loss will always reduces. So heat loss will always reduces because your RC is 10 and you manufacture greater than RC. So in that case, it always reduces. Okay, it always reduces. So adding the insulation will reduce the heat loss. Simple. So just understand the funda, check this diagram, check this RC and R combination. So these are some previous gate questions. From that you get the fair idea that how to solve the critical radius. Of course I agreed, there are a lot of things, derivations are there, so much concept is there, but my today agenda is to just give you the brief idea about the critical thickness so that you can solve any question. So today's my agenda is about to solve the numericals, and I did that. Hope you understand little bit. If you practice more and more, you will get more confident. So this is from my side on the today's discussion on critical thickness of insulation. Again we will meet in some other day with some other topics. So keep subscribing the ACE Academy channel, and for more videos keep on watching the ACE Academy channel. Okay, thank you.
I am Nikhil Kumar Saha. I got AIR 1 in Gate Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go. So it helped me to cope up with this type of numericals, and also I got to know through different multiple choice questions multiple select questions which are now in the GATE mechanical they have introduced. So I got very good quality questions, so it helped me in preparation a lot. I am Nikhil Kumar Saha. I got AIR 1 in GATE Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go. So it helped me to cope up with this type of numericals, and also I got to know through different multiple choice questions, multiple select questions which are now in the GATE mechanical they have introduced. So I got very good quality questions, so it helped me in preparation a lot. I am Nikhil Kumar Saha. I got AIR 1 in GATE Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go. So it helped me to cope up with this type of numericals, and also I got to know through different multiple choice questions, multiple select questions which are now in the GATE mechanical they have introduced. So I got very good quality questions, so it helped me in preparation a lot. I am Nikhil Kumar Saha. I got AIR 1 in GATE Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go. So it helped me to cope up with this type of numericals, and also I got to know through different multiple choice questions, multiple select questions which are now in the GATE mechanical they have introduced. So I got very good quality questions, so it helped me in preparation a lot. I am Nikhil Kumar Saha. I got AIR 1 in GATE Mechanical 2022. I was enrolled in ACE online test series program. So test series, whether it would be subject wise, topic wise or full length test, it helped me to improve my numerical solving skills in all the domain of the subjects that are included in mechanical. It helped me to cope up with the new numerical type of problems which normally students face difficulty in solving in first go.